Hello guys, welcome once more to another video in our YouTube channel. So today we are going to be looking at question number 5 of the June 2024 solution series for Pure Maths paper 2 mechanics/statistics. So if you have not watched the previous videos from question 1 to question 4, endeavor to go watch those videos and like, share and subscribe to the YouTube channel. If you have any worry, the comment section is open for you to post your worry, or you can get directly to me on WhatsApp. Alright, without wasting much of your time, let's go straight away into what we have for you today. Alright, so question 5 has Roman 1 and Roman 2. Roman 1 reads, the parametric equations of a curve are given by x equal to 1 plus t, y equal to 2 plus 1 on t, where t not equal to 0 is actually a parameter. Show that the equation of the normal to the curve at a point when t is equal to 2 is 8x minus 2y minus 19 equals 0. Then find the value of t at the point where the normal meets the curve again, allocated for 6 marks. Roman 2. A new primary school intends to recruit a head teacher and 7 other teachers. There are 3 male and 2 female applicants for the position of the head teacher, 4 male and 6 female other participants for the teaching position. Find the number of different ways of selecting a staff of 8 if gender equity must be respected. 7 marks. Alright, so let's get started with Roman 1 of question 5. Alright, so I'm going to read the question again. We try to analyze together, then go straight away to the solution. The parametric equations of a curve have been given to you. Parametric means x and y depends on a parameter t. If we eliminate this parameter, we are now going to have the Cartesian equation of the curve where x will be directly related to y. Okay, t is a parameter and it is not 0. It is not 0 because we have a quantity 1 on t and we can't divide by 0. Now we need to show that the equation of the normal to this curve at a point when t is equal to 2 is given by 8x minus 2y minus 19 equal to 0. Then we find the value of t at a point where the normal meets the curve again. So we are going to begin with the first part of the equation, which is asking us to get the equation of the normal. In fact, to justify that this is the equation of the normal. So basically, to do that, we are going to find the equation of the normal, and if it gives us this, we conclude that we have proven that that is the equation of the normal at a point when t is equal to 2. Alright, so a normal is a line, so it has a gradient. Alright, now the normal to the curve is at a point. So generally, a line is defined by the equation y minus y0 equal to m into x minus x0. x0 and y0 are the x and y coordinates of the point where that line is touching the curve. M here is the gradient of the line, so I'm specifying that it is mn, so it's the gradient of the normal. So there are just 3 things we need to find here and then proceed. We need to find the y coordinate of the point, the x coordinate of the point, and the gradient of the normal. So let's begin with the x and y coordinate of the point. Now we know that the point is actually when t is equal to 2, and since x and y are both in terms of t, once I replace t with 2 in x equal to 1 plus t, the value that 1 plus t gives me is the x coordinate of the point, which is x0. Once I replace t with 2 in y equal to 2 plus 1 on t, the value I have becomes the y coordinate of the point, which is y0. So we just have to replace t to be 2. Once we replace t to be 2, your x becomes x0, and x0 will give us 1 plus 2, which is 3. If you replace t to be 2, your y becomes y0, and y0 will give us 2 plus half, which is 5 divided by 2. So we are just left to get the gradient of the normal. Alright, but to find the gradient of the normal, we must find the gradient of the tangent. Then we use the fact that the product of the gradient of the normal and the gradient of the tangent is -1, because the tangent and the normal are always orthogonal to each other, that is perpendicular to each other. So the gradient of the tangent, which is small m, times the gradient of the normal, which is mn, must always give us -1. Your small m, like I said, is a slope or the gradient of the tangents. Now, to find the gradient of a tangent at a point, we are going to use the derivative. Alright, so the definition is that the gradient of the tangent at a point to a curve is dy by dx at that point. At that point, t is equal to 2. So we need to find dy by dx, okay? Now to find dy by dx, we are going to use the chain rule because x and y are in terms of t. So to get dy by dx, we use the chain rule, which says that dy by dx is dy by dt divided by dx by dt. Okay, so since y is in terms of t, we can get dy by dt, and since x is also in terms of t, we can get dx by dt. Just by looking, what is dx by dt? It is equal to 1, because when I differentiate this one here, I get 0. When I differentiate t, I get 1, because I'm differentiating with respect to t, differentiating x with respect to t. So dx by dt is 1. So your dy by dx will just be equal to dy by dt, because when you take dy by dt divided by 1, you just get dy by dt. Now what is dy by dt? We need to differentiate 2 plus 1 on t. When I differentiate 2 with respect to t, it gives me 0 because 2 is a constant. When I differentiate 1 over t with respect to t, what do I have? We are going to write 1 over t as t to the -1. So if I differentiate t to the -1 with respect to t, I drop down the -1, then I take t to the power -1 minus 1. That's called the power rule of differentiation. So this becomes -t to the -2, which is equivalent to -1 over t squared. So it means that my final answer is just -1 over t squared, because we have to divide by 1. Alright, but when you divide anything by 1, we get that thing. So dy by dx is equal to -1 over t squared. So what is now my gradient? My gradient is dy by dx at t equal to 2. So replacing t to be 2 here, t squared becomes 4. So my gradient is -1 divided by 4. So this is the gradient of the tangent. What is now the gradient of the normal? It is -1 divided by the gradient of the tangent. So the gradient of my normal is -1 divided by -1/4, which is going to give me 4. Alright, I just now replace everything back into the equation of my normal. So I'm going to have y minus 5 on 2, because y0 is 5 on 2, equal to mn, which is 4, into x minus x0, which is x minus 3. Multiply all through by 2, I'm going to have 2y here. I'm going to have minus 5 equal to 8 into x minus 3. Now expand, we are going to have 2y minus 5 equal to 8x minus 24. If I send everything to the right hand side, I will have 8x minus 2y. -24 plus 5 is -19. So at the end of the day, we have 8x minus 2y minus 19 equal to 0. So we have succeeded in showing that the equation of the normal to the curve at a point when t is equal to 2 is 8x minus 2y minus 19 equal to 0. Now in the next question, we need to find the value of t at the point where the normal meets the curve again. Okay, now if the normal is meeting the curve, it means that at that particular point they have the same x coordinate and they have the same y coordinate. Okay, so all we have to do is replace the x coordinate of the curve in the x coordinate of the normal and replace the y coordinate of the curve in the y coordinate of the normal, because at that particular point they are the same, so they should have the same x value and the same y value. So generally the normal is going to meet the curve again if and only if we have 8 times the x coordinate of the point of the curve minus 2 times the y coordinate minus 19 equal to 0. This is just telling us that the x and y coordinate of the curve should be equal to the x and y coordinate of the normal. Or we can say the x and y coordinate of the curve should satisfy the equation of the normal. So if we expand everything, we are going to have 8 plus 8t minus 4 minus 2 on t minus 19 equal to 0. Now we further simplify. we are going to have 8 minus 4 is 4, 4 minus 19 is negative 15. So you are going to have 8t minus 2 on t minus 15 equal to 0. Multiply both sides of the equation by t and rearrange to have a quadratic equation. We are going to have 8t squared minus 15t minus 2 equal to 0. We can easily factorize to get 8t plus 1 times t minus 2. If we solve this, you are going to have t is equal to 2 and t is equal to negative 1 divided by 8. But again, t equal to 2 was when the normal met the curve at a particular point. So we are going to reject t equal to 2 because we already used it. Alright, so it means that the required value of t for you to meet the curve again is t equal to negative 1 divided by 8. Now let me try to analyze it graphically so that we see exactly what is happening.